Your autonomous AI agent isn't failing because your model is too weak. It's failing because you built it wrong. You upgraded to the most advanced model. You added more parameters. You increased context size. And it still drifts, still hallucinates, still spirals out of control. Because the problem was never intelligence. It was architecture. Today, I'll show you how to build a working autonomous agent using only free local models. No expensive APIs, just correct placement. If you zoom out, every serious autonomous system reduces to a few core roles. Not one supermind, but layers. Let's break them down. First is the planner. This is the strategist. It looks at a goal and asks, what are the steps? What dependencies exist? What tools will I need? What order makes sense? This layer doesn't touch the terminal. It doesn't write shell commands. It doesn't debug logs. It thinks in abstractions. If the planner is weak, everything downstream collapses. Because bad strategy produces expensive mistakes. Next is the tool-using agent. This is discipline. It doesn't think philosophically. It formats correctly. It produces structured output, valid JSON, proper arguments, clean tool calls. Autonomous systems fail constantly here, not because reasoning was wrong, but because a bracket was misplaced. One malformed function call can derail the entire loop. This role demands precision. Third is the execution agent. Now we're at the terminal, reading logs, fixing errors, writing scripts, updating files. This layer operates in concrete reality. It doesn't speculate. It reacts. If this agent hallucinates commands or misreads stack traces, the system breaks. This role requires technical grounding. Last is the reflection layer. This is where intelligence stabilizes. After action comes evaluation. Did the plan work? What failed? What should change? What should be stored? Reflection compresses chaos into memory. Without this layer, agents repeat the same mistake forever. But here's the key. Reflection doesn't need genius-level IQ. It needs coherence, clarity, compression. And once you see these four roles, something becomes obvious. No single free model is optimized for all four simultaneously. But each model excels somewhere, which means the real breakthrough isn't upgrading intelligence. It's assigning intelligence correctly. Now let's match actual free Ollama models to each of these roles. This is where it gets practical. Now we stop speaking in theory. Let's assign real models. All free. All runnable in Ollama. All usable inside OpenClaw. But we're not ranking them. We're placing them. First, the planner role, use Llama 3, either 8 billion or 70 billion. If you need structured reasoning, start here. Llama 3 is balanced, strong at instruction following, and stable in multi-step reasoning without spiraling under pressure. It's not perfect, but it holds a plan together, and that matters. The planner's job is abstraction, breaking a goal into steps, sequencing tool calls, and deciding priorities. Llama 3 handles strategic decomposition well, especially the 8B model for local setups. Think of it as the project manager, not writing code, not formatting JSON, but designing the path. Next, the tool-using agent. Use Qwen 2.5, 7B, or 14B. This is where alignment really matters. Qwen is extremely strong at structured output, clean formatting, stable JSON, disciplined responses. In autonomous systems, formatting errors are catastrophic. One malformed argument and the loop collapses. Qwen excels at strict output requirements. It's not the philosopher, it's the systems engineer. If you care about reliable tool invocation inside OpenClaw, this is a strong choice. Then the execution agent, use DeepSeek Coder, 6.7 billion or 33 billion. DeepSeek Coder is optimized for code reasoning, reading stack traces, fixing bugs, generating shell commands, editing files. Autonomous systems spend massive time in error correction, and generic models often hallucinate commands here. Code-specialized models reduce that risk. When your agent starts touching real files, This model becomes valuable. It thinks concretely. Less talk. More fix. For the reflection layer, use Mistral 7B Instruct. Reflection doesn't need maximum IQ. It needs speed, coherent summaries, clear evaluation, compression of logs into memory. Mistral is lightweight and fast. Perfect for what just happened? What went wrong? What do we store? It's the internal auditor, not running the company, but preventing repeat mistakes. Finally, for the memory compression or helper agent, use Phi-3 Mini. Sometimes you just need small, efficient reasoning. Rewriting notes, condensing context, rephrasing goals, filtering noise. Phi-3 is extremely lightweight. It won't design your architecture, but it can manage context economically. And in long-running agents, context efficiency is survival. This is infrastructure thinking. And once you think this way, free models stop looking weak. They start looking composable. Now let's see what a full OpenClaw stack actually looks like when you combine them. Imagine we're building an autonomous agent inside OpenClaw, a system that can research a topic, write code, test it, debug errors, refine its strategy, and store memory over time. At the top of the stack, the goal enters the system, and Llama 3, the 8B version, takes responsibility for shaping it into something actionable. Rather than jumping straight into execution, it decomposes the objective into structured steps. Gather the necessary data, analyze the findings, generate a script, execute it, and finally evaluate the results. It decides which tools should be invoked and in what sequence, setting direction without ever touching the terminal. This layer is not concerned with logs or syntax errors. Its role is strategic abstraction, maintaining coherence and ensuring that the overall roadmap makes sense before anything begins to run. Once the plan is clear, Qwen 2.5 translates that structure into disciplined action. It generates clean JSON, correct arguments, and properly formatted API calls, minimizing ambiguity and eliminating narrative drift. Many autonomous systems fail at this exact layer due to formatting instability. But here, execution requests are precise and machine-ready. When commands reach the environment, DeepSeek coder engages with reality. Logs stream, errors surface, and stack traces reveal what actually happened. It reads the signals, identifies failure points, modifies files, and fixes syntax or logic problems. This is the layer that grounds the system in execution rather than intention. After action comes reflection, handled by Mistral 7B. The system pauses long enough to analyze what worked, what failed, and whether the flaw was in planning or execution. It compresses logs into insights and feeds lessons back into the loop, preventing the agent from repeating mistakes blindly. Over time, memory grows noisy and inefficient, which is where Phi-3 becomes essential. It condenses notes, restructures context, and prevents token bloat from destabilizing reasoning. It's a quiet layer, but it protects the long-term stability of the entire system. When you step back, what emerges is not a single giant brain but a distributed cognitive stack. Each model operates within clear boundaries, reducing overload and increasing reliability. The real power doesn't come from putting the smartest model everywhere. It comes from orchestration, placing the right model in the right position so the whole system becomes stronger than any single part. Now let's be honest. Free local models are powerful, but they are not magic. And if you overestimate them, your agent will collapse quietly. Here's where they still struggle. First, long horizon stability. Free models can handle multi-step reasoning, but over 20, 30, 50 iterations, drift increases. Goals mutate. Context degrades. Plans lose coherence. They don't always remember why they started. That's not a failure of intelligence. It's a limitation of depth and training scale. Long-term autonomy is hard. Second, deep strategy generation. Free models are strong workers. They are not yet strong CEOs. If the task requires inventing new business models, designing novel research strategies, synthesizing across multiple unknown domains. They can assist, but they rarely originate breakthrough structure. Their strength is execution, not high-level innovation. Third, persistent memory architecture. Autonomy across days or weeks requires stable memory integration. Free models struggle with rereading compressed memory, maintaining identity consistency, avoiding recursive confusion. Without external scaffolding, they forget who they are over time. Memory isn't solved by model size alone. It's an architectural challenge. And last, tool reliability under stress. Under pressure, ambiguous logs, edge cases, unexpected outputs, smaller models sometimes hallucinate fixes. Not because they're unintelligent, but because confidence calibration is weaker. In critical systems, that matters. But here's the key insight. These are not reasons to avoid free models. They are reasons to design around them. Autonomous AI does not require genius everywhere. It requires containment of weakness, guardrails, specialization, short feedback loops, infrastructure. And that's the mindset shift. Stop asking, can this free model replace GPT-4? Start asking, where inside the architecture can this model operate safely and effectively? Because once you define clear boundaries, even small models become reliable components. And reliability, not brilliance, is what builds autonomous systems. Now zoom out, because this isn't really about free models, and it isn't really about OpenClaw. It's about something bigger. For years, the AI conversation has revolved around one axis: bigger models, more parameters, higher benchmarks, more compute. The assumption is simple: intelligence scales upward. But autonomous systems reveal something different. They scale sideways, through orchestration, through specialization, through layered cognition. Not one giant brain, but a structured cognitive stack. And once you understand that, a powerful implication emerges. You don't need the smartest model everywhere. You need a competent planner, a disciplined tool user, a grounded execution layer, a fast reflection loop, a memory compressor. That's infrastructure thinking. And infrastructure is what creates stability. Free models are early building blocks. They aren't AGI, but they show us something important. Autonomy doesn't require perfection. It requires coordination. The road to AGI may not be about building a single supermodel that dominates all tasks. It may be about building systems where intelligence is distributed across roles, where weaknesses are isolated, and where feedback loops correct drift. That's a very different direction. Not vertical escalation, horizontal integration. And if that's true, then the future of autonomous AI won't be defined solely by who has the biggest model. It will be defined by who builds the most coherent architecture. And architecture is something you can start building today. Even with free models,